Hi everyone, welcome back. Today we are solving count covered buildings. So this problem is pretty straightforward. So we will be given an array called buildings, and each building will have an x coordinate and a y coordinate, and the building is considered covered if there is one building in all four directions. So left, right, above, and below. And we want to return the number of covered buildings. So if you look at this example, we return 1 because there's one building right here at 2 and 2 where it is covered in all four directions. So return 1. This one, we return 0 because no buildings are covered in all four directions. And in this one, we return 1 because there's one building at 3 and 3 where it is covered to its up, to its right, to its left, and to its down. So we return 1. Now that we have seen some examples, let's get to how we can solve this problem. So one way we can solve this problem is we can set up 4 arrays. Min row will tell us the minimum possible row there is at each column. Max row will tell us the maximum row that is covered at each column. Min col will tell us the minimum column that is covered in each row, and max column will tell us the maximum column covered in each row. And we will initialize max row and max column with 0, and the length will be n plus 1, and min row and min column will be initialized with n plus 1, and the length will also be n plus 1. And also for rows, this will represent column 1, column 2, and column 3. And this doesn't mean anything. It just had to be there because I'm trying to show how the array will look like when we code it out. And same here. This will be row 1, row 2, row 3, and these two do not mean anything. So what we will do is we will iterate through the input array, update these 4 arrays along the way, and then we will iterate through each building again and check if it meets the constraint or not. If it does, then we can increment the result by 1, and after iterating through, we can return the result. So let's go over this example real quick. And also these also don't mean anything, but again, I'm trying to show how it'll look like when I code out the problem. So first, we will update the minimum row and maximum row at column 2 to 1, and the minimum column and maximum column at row 1 to 2. As you can see, that's the case here. Move on to the next one. We will update the max column and minimum column to 2 at row 2, and we will update the max row to 2 from 0. And move on to the next one. Now at column 2, the maximum row is now 3 and the minimum row is still 1. And at row 3, the minimum column and maximum column now is 2. Move on to the next one. We will update the minimum column to 1 at row 2, and we will update the maximum row at column 1 to 2. Now move on to the last one, 2 and 3. If we look at column 3, we will update the min row and max row to both 2. And if we look at row 2, the max column is now 3 and the minimum column is still 1 at row 2. So now we have looked through all the buildings. Now we will iterate again and see if they fall within constraints. So if we look at 1, 2, the minimum row at column 2 is 1 and they are equal. So you know this one is not surrounded, or in other words covered. So move on to the next one. 2 is covered because 1 is smaller than 2, 1 is smaller than 2, 3 is larger, it has a larger row, it also has a larger column than 2, so it is surrounded, so we can increment result by 1. Move on to the next one. We see that at column 2, the max row is equal to row 3, so this one is not covered. Move on to the next one. We see that at row 2, the minimum column is 1, which is equal to column 1, which implies that it's not covered. Move on to the next one. We see that at row 2, the maximum column is 3, and this is column 3, so that one is also not covered. So we can return the result as 1. And the time complexity would be O of n, where n is the number of buildings, because we will have to iterate through the number of buildings. And the space complexity would be O of n squared, because the space that we use for these 4 min row, min column, max row, and max column will be n squared space. So now let's get to the coding part. So first we will set up the 4 arrays. So max row will be 0 times n plus 1. Min row will be n plus 1 times n plus 1, even though n will work, but I like using n plus 1. and max column would be 0 times n plus 1, and minimum column would be n plus 1 times n plus 1, although you can use n for the elements in the array. Now we will loop through the buildings. I will use RC in buildings, R for a row, C for column. So it'll be like R could be the X and C could be the Y. And the max row of C would be the max between max row of C or the row. And min row will be the minimum between min row of C and R. And max column of R would be updated to the maximum between the maximum column of R and C. And same for a minimum column, the minimum between minimum column of R and C. Now we will initialize result and loop through the buildings. Check for constraints. So if R is greater than min row of C and R is less than max row of C and C is greater than the minimum column of R and C is also less than the maximum column of R, we can increment result by 1 and return result. Let's see if it works. Okay, perfect. Thank you all for watching. Hope this is helpful. If you have any other questions or comments, feel free to leave them in the comments section, and I hope to see you all again soon.